you have to think of numbers you can take the cubed root of. Okay, so start off by graphing these, please.
Oh yeah, this is where you want to go. We're only going over like 3 numbers. How are you saying? See. Oh, you definitely have. So they're good for one.
It's the question I just did. It's the question.
It's that only ice on there. It doesn't like drive it.
Next time I go to the
I just like I just think you shoot it. No, it's 2-8. It is 8-2, bro. It is 8-2, bro.
Alright, so our meters are -8, -2, -1, -1, 1, 1, and 8, 2. Because these are numbers we can take the cubed root of. Now, my transition point, where does it shift to? Right 3. So I'm going to start off at the point 3, 0. And then from this point, I'm going to go left 8 and down 2. Left 1, down 1. Right 1, up 1. And right 8, up 2. It's kind of off the graph, but we'll fudge it a little bit. And so our graph should look something like that. The right-hand side of my graph looks much better than the left side of my graph. There we go. All right, G of x, where's the transition point located? Down 4. So 0, -4 is where I'll begin. Now, because of the 2, it takes and multiplies our y's by 2, which causes a vertical stretch. All right, so when I go left 8, I'm going to go down 4. When I go left 1, I'm going to go down 2. Right 1, up 2. Right 8, up 4. So this cube root has been vertically stretched. And then finally this one. With this one, when we take those normal moves of -8, -2, -1, -1, 1, 1, and 8, 2, the negative out in front is going to change all of these to the opposite. So instead of being increasing the entire function, now this function will be decreasing. Where's the transition point for h of x? -4, 3. Awesome. So that's where I'll start at -4, +3. And so when I go left 1, I'm going to go up 1. If I went left 8, I'd go up 2. Right 1, down 1. Right 8, down 2. So this one has been, this is crazy. It's hard to do on the movie. There we go, something like that. It shouldn't have this extra hump right there, sorry. Yes?
Can there ever be a negative inside the root side?
Sure.
No, I'm saying like right before the x.
Yep.
What does that do?
On this one, it doesn't look any different. Remember, we did study the square root, and we talked about with square root, if we did it like this, it opens this way. But if we did a negative inside here, it opens this way. So it causes a reflection over the y-axis. But with the cube root, if you reflect over the x or the y, it looks the same. It doesn't look any different. So I don't normally give you one like that because it doesn't look different.
So it'd be the same thing as that?
It looks the same.
Okay. The squares.
Alright, so now let's take a look at all of these. Where is this function equal to 1? Alright, so we're looking at where this function equals 1. And it's right here. I didn't plot that point for some reason. It's right here. And what is the x value right there where that function equals 1? 4. Okay, where does this function equal -2? That would be right here. So what is that x value right here? 1. Alright, where does this function equal +2? It's right there. So what is that x value? -3. Okay, so that's when we have an equivalence. Here we have the inequalities. So when we look at these, we're looking at something different. Where is this function greater than 1? So we're looking at this part. It's not equal to 1, it's just greater than 1. So it's from 4 to infinity. If it had said equal 1, we would have included the 4 also. But it doesn't, so we do not include the 4. Okay, where is this function less than -2? So we're looking at this. Where is it less than -2? So that is from -infinity to, what is that x value? 1. Now we won't include that one either because there's no equal to. Now on the last one, where is it less than or equal to 3? Well, it's less than or equal to 3 over here. So this one does have the equal to. So that is from -4 to +infinity. That function is less than or equal to 3. Any questions about how to use the graph to solve these? Alright, now at the bottom we talked about algebraically. So first let's consider the cubed root of x equals 2. What value of x has a cubed root of 2? What number can I take the cubed root of? 8. Okay, so if we were solving this, what would we do to both sides to get 8? Cube. So just like yesterday, solving these equations works the same way. So you try to get the cubed root by itself. So for this one, we would subtract 3. So we get 2 times the cubed root of x plus 4 equals 4. Divide by 2. So we get the cubed root of x plus 4 equals 2. And then we cube both sides. So we get x plus 4 equals 8 and x equals 4. Now yesterday we did square roots. And square roots cannot equal negative numbers. But can cube roots equal negative numbers? They can. So we shouldn't get the no solution answer with cubed roots. And if we think about the graph, isn't the graph continuous? Isn't every value accounted for? Yeah. So we should not get no solution. Okay, so I want you to try these real quick, and then we'll go over them in just a sec. Those of you that are listening to the video, if you'll pull up the notes, you'll see the answers to these questions. Everybody gets 2 things for homework. The back of this worksheet, plus there's a secondary review. And we'll talk about when that's due. That review is not due until Thursday.